Module 10, Lecture A, Planning Your Project. By the end of this lecture, you will be able to select a beginner-appropriate Python project idea that matches your interests and skills, break the project into clear, manageable tasks and components, and design a simple plan that maps tasks to Python features, such as functions, loops, and files. Picking project ideas. Right-sized projects. When choosing a project, pick one that is large enough to be meaningful and challenging, but still small enough to finish with your current skills and available time. A project that is too small will not give you real practice with planning and debugging. However, a project that is too big, such as building a full social media platform, can quickly become overwhelming and discouraging. Aim for something that stretches you just beyond what you already know, so you can tackle it step by step without it feeling impossible. To judge whether a project is the right size, think about what it takes to finish it and break its features into small, manageable parts. A simple text-based quiz game, for example, only needs basic elements like asking questions and keeping score, which you can handle with beginner Python skills. A multiplayer quiz platform, however, demands more advanced technologies you may not know yet. Projects like a personal budget tracker or a study helper are good choices because they are interesting, rely mainly on fundamentals such as variables and loops, and still give you a meaningful challenge at your current level. When choosing a project, be realistic about your time, current skills, and how comfortable you are with learning on your own. If you are new to programming and short on time, pick something small that you can explain simply and still finish, even if you run into problems. A basic command line to-do list or a simple habit tracker are good examples that can start very small and grow only if you have extra time. By matching your project to your real limits, you are more likely to complete it and feel satisfied with the result. Beginner-friendly project ideas. When choosing a project idea, look for simple, everyday problems that use basic inputs and produce clear outputs. Aim for something you can explain in a few sentences, such as a to-do list manager or a quiz game, without advanced math or graphics. These kinds of projects rely on straightforward logic and small, organized sets of data. They are easier to test, help you practice structuring your Python code, and build your confidence as you learn. To find beginner-friendly programming project ideas, look at your daily routines and hobbies and ask where simple automation could help. If you enjoy reading, you might build a basic tool to track book titles and your progress. If you are into fitness, you could create a workout logger to record exercises and durations. Gamers might try a number guessing game or a simple rock, paper, scissors opponent. These small projects use straightforward data and interactions. Help you practice core programming skills without complex tools and stay connected to your interests so you remain motivated while debugging. When you choose beginner projects, start with a simple version that is already useful or fun, and then expand it over time. For instance, a budget tracker might begin by just recording expenses and showing a total, and later you can add categories or spending limits. A flashcard tool could first use fixed questions, then grow to shuffle cards or track your progress. This gradual approach keeps the work manageable. encourages creativity and helps you avoid overly ambitious ideas that never get finished. In the end, a modest project you complete will teach you more and feel more rewarding than a complex one you abandon. Reusing course patterns. When choosing a realistic project, build on patterns you have already practiced instead of starting from scratch. Think about earlier exercises, such as a text-based game or a menu program, that used user input, validation, data storage, and output. By reusing and adapting these familiar structures, you lower the mental effort of learning new ideas and can focus on extending what you already know. This makes the project more achievable and helps you picture how the pieces will work together before you start coding. Reusing patterns from your course means understanding the structure of an example and applying it to something that interests you, rather than copying it exactly. For instance, a multiple-choice quiz program can become a language drill, a biology self-test, or a sports trivia game by keeping the same core idea of storing questions and answers, presenting them, collecting responses, and scoring. By changing the theme and adding features like high scores or hints, you make the project more personal and engaging while still working within a familiar framework. This approach supports creativity but keeps your project at a manageable scope. You can make your project more advanced while keeping it manageable by combining patterns you already know. For example, you might merge a menu-based program with file handling to build a habit tracker that records and reviews progress. You could also blend a number-guessing game with simple data analysis to track and summarize how a user improves over time. By reusing familiar building blocks in new combinations, you stay within your skill level while still creating a clear, achievable project from idea to finished product. Planning project tasks. Project feature list. Before you start coding, first get a clear, user-centered idea of what your program is for. Make a simple feature list that explains in everyday language what the program will let people do, as if you were describing it to a non-programmer friend. For example, a budget tracker might let users add and categorize expenses and see summaries, while a vocabulary tool might let them add words and track scores. This kind of list connects your initial idea to concrete actions you can later turn into code. When planning your program, clearly separate core features from optional ones. Core features are the essential functions that make the program usable, while optional features are nice additions if time allows. Focusing on the core first prevents overcommitment and ensures you still deliver a working product even if you run out of time. This approach helps you keep the main promise and usability of your project intact. When creating a project feature list, be specific and realistic, matching what you can actually build with your skills and time. Avoid vague goals like saying the program is user-friendly, and instead describe concrete user actions, such as searching for a book by title or exporting a playlist. Think through how users will interact with your program and write each possible action as a separate feature. You can look at tools you already use, like note-taking apps, to inspire features you might replicate. A clear, detailed feature list then helps you break work into subtasks, estimate effort, and plan your project within your timeline. Breaking work into subtasks. Once you know what your project should achieve, break the goal into small, concrete tasks. Instead of thinking only about building a budgeting app, identify the specific actions it must support, such as entering data or viewing summaries. This turns a vague idea into manageable steps and exposes complexities or missing details before you start coding. By focusing on user activities and translating them into program steps, you create a clear plan and make the project feel more approachable. To create subtasks, picture how a user moves through your project and identify what the system must do at each step. In a quiz app, this means turning actions like choosing a topic, answering questions, and getting feedback into smaller tasks. These tasks include presenting options, recording choices, showing questions, checking answers, and updating scores. This approach works for many kinds of projects, as long as each subtask clearly connects a user action to a specific system response and outcome. When refining subtasks in a project, make each one small enough to understand on its own, but still meaningful to the overall goal. Avoid vague, broad tasks that bundle many responsibilities together, and instead define clear, specific actions, such as asking for a user's name and saving it. Group related subtasks naturally, for example by data handling or user interface work, to keep your thinking organized. This method creates a clear roadmap, makes the project feel more manageable, and lets you see steady progress as you complete each part. Task execution order. After identifying the main tasks in your project, you should decide the order in which to do them so you avoid wasted effort and unnecessary features. A useful method is to imagine the user's journey from start to finish, then work backwards to find what must be built first. For example, in a budget tracker, users can only see summaries after their transactions are stored, and storage depends on handling input correctly. This backward tracing reveals a logical sequence, such as starting with input and storage, then adding calculations, and finally layering on optional features, turning a rough idea into a clear, ordered plan for coding. To manage project tasks effectively, group them into foundational work, core functionality, and enhancements, and complete them in that order. Foundational tasks are the basic setup, such as the project structure and data storage. Core functionality covers the essential features that make the application actually useful. Enhancements are optional extras that improve the user experience. By focusing on foundational and core tasks first, you quickly achieve a working project that you can then refine and improve over time. When planning the order of your tasks, think about both your learning curve and your motivation. Start with simpler tasks to build confidence, then move on to more complex ones, and alternate so you do not feel overwhelmed. Keep track of which tasks depend on others, focus on usability, and choose an order that gives you steady, visible progress. Be prepared to adjust your plan as new requirements appear or unexpected challenges come up, so you stay engaged and keep moving forward. Planning the solution. Choosing Python features. When planning a Python project, assign specific language features to clear responsibilities. Use loops to handle repeated actions, functions to group related tasks, and file handling to save data between sessions. By matching each part of the project to the right feature, you turn a vague idea into a concrete, workable plan. When planning a Python project, It is important to choose features that keep your code clear and flexible. Using functions to group related tasks, such as collecting, displaying, and searching data, helps organize the program. Loops handle repeated actions, like going through stored items or running a menu, without copying code. Together, these tools reduce duplication and make it easier to change formats or add new options later, without rewriting large parts of the program. When you build a project that needs to keep information between runs, such as a personal finance tracker, you must use file handling so the data is not lost when the program closes. Different parts of the program can be responsible for saving, loading, and updating this data. You typically use loops to read through files and functions to turn each line into a useful format. This structure is common in beginner projects like reading logs or tracking inventory, and helps keep the program organized while doing something practical. Python code. Choosing Python features. This lesson shows how to connect project responsibilities to specific Python features by planning a tiny recipe helper. It explains how to break the task into clear parts and then implement them using functions to organize actions, loops to repeat steps like going through ingredients, and file handling to save or load recipe data. The focus is on demonstrating how these core Python tools work together in one simple, structured example. This line serves as a placeholder to remind you to install any libraries the script needs in order to run. It highlights the importance of making sure all required dependencies are available, especially when the script uses external packages beyond the standard Python library. Including this reminder helps keep the script working correctly across different systems and environments. We define a function that collects information for a single recipe using preset values instead of interactive input. It sets a recipe title, a string that represents the ingredients, and a short description of the cooking steps. The function then returns these three pieces of information together in a dictionary, which neatly packages the recipe details in a structured form. The display recipe function is used to show a recipe in a clear, readable way. It first adds a blank line to separate this output from anything printed before. Then it prints the recipe name, which it looks up in the dictionary using the name key. After that, it prints the ingredients, taken from the ingredients key, and finally the cooking steps, taken from the steps key. In this way, the function neatly formats and displays all the main parts of a recipe. The Save Recipes function writes a list of recipes to a text file in a simple, consistent format. It opens the chosen file in write mode, creating or replacing it as needed, and uses a context manager so the file is closed automatically. For each recipe, it builds a single line by joining the recipe name, ingredients, and steps with a vertical bar separator. It then writes this line, followed by a new line character, so each recipe occupies its own line. This makes the stored recipes easy to read and parse later. This function creates an empty list to hold recipes, then tries to open a file and read it line by line. For each line, it trims extra spaces, splits the text into 3 parts using the pipe character, and treats these parts as the recipe name, ingredients, and steps. It then builds a dictionary for each recipe with these 3 pieces of information and adds it to the list. If the file does not exist, the function quietly handles the error and continues. In the end, it returns the list of recipes, which may be empty if the file was missing or contained no usable data. This function searches a list of recipes for one with a specific name. It goes through each recipe and compares its name, converted to lowercase, with the search name, also in lowercase, so the search is not affected by letter case. If it finds a match, it immediately returns that recipe. If it finishes checking all recipes without finding a match, it returns a special value indicating that no recipe with that name exists in the list. A main function controls the overall flow of the recipe program, showing how loops, functions, and file handling work together. It sets the recipe file name, loads any existing recipes, and then uses a preset choice to simulate user input. Based on this choice, it can collect and add a new recipe, search for and display a recipe by name, or save all recipes back to the file, printing a confirmation message in each case. If the choice does not match any valid option, it prints an error message. The main function only runs when the script is executed directly, which helps avoid problems in certain environments. This script shows a simple recipe management system in Python using functions, loops, and file handling. When it runs, it loads any existing recipes from a file, then simulates adding a new recipe with preset values as if a user had entered them. The new recipe is stored in a list, saved back to the file, and can be searched by name, so its details are displayed if found. The code also handles missing files safely, so the program does not crash, illustrating how to organize a small project with clear, separate tasks. Project data requirements. Before choosing specific Python features, first picture how data will move through your project from user input to final result. Decide what information the program must collect, process, and store. For example, a budget tracker focuses on income, expenses, and balances, while a flashcard tool focuses on questions and how often they are reviewed. Clarifying this data flow turns a vague idea into a concrete plan and prepares you to select appropriate Python structures and features. Once you know what data your project needs, decide how to group it and where it should live while the program runs. Related pieces of information, such as a task's details or a recipe's components, can be stored together, while single values can be kept in simple variables. You should also think about how long each piece of data needs to exist, distinguishing between short-lived data used only for calculations and data that must persist across user actions or program runs. This helps you choose between keeping data in memory for quick, temporary use or saving it to files for long-term storage. When planning a program, think about how your data will change over time and how users will work with it, because this drives your control flow and features. Decide which pieces of data are updated often and which stay mostly the same. For example, a habit tracker needs to let users add habits and log completions, which calls for loops to update records and file operations to save history. A contact manager needs repeated searching and editing, which also relies on loops and careful input handling. By matching these data interactions to Python tools like loops and file handling, you connect what your project must do with how you will implement it. This script shows how to manage habit tracking data in Python by creating habit records as dictionaries with key details, such as the habit name, target days, and completed days, and storing them in a list. It simulates progress by increasing the completed days for each habit and then prints a summary of how many days remain to reach each target. The user is then asked whether to save the updated data to a text file for future use or keep it only in memory for the current session. Overall, it demonstrates the difference between temporary and persistent data storage while integrating basic user interaction and file handling. Designing user flow. Designing user flow means picturing every step a user takes when interacting with your program, from how they start to how they finish. Before writing any Python code, think through the user's journey: how they begin, what information they enter, how the program reacts, and how the session ends. For example, a budgeting tool might greet the user, ask for income and expenses, show a balance summary, and then let the user adjust or save the results. Planning this flow first helps you see where you need input prompts, loops, and functions, so you can build the code around a clear, user-focused experience. After outlining the user's journey, divide it into stages that match how your program will run. For a quiz app, this might mean an introduction, a sequence of questions, checking answers and updating scores, and then showing results and feedback. Connect each stage to Python concepts, such as loops for going through questions, functions for scoring, and file operations for saving scores. As you design this flow, decide when to ask for input, validate answers, handle errors, and pass data between stages. This method helps you move smoothly from planning the user experience to implementing the code. When designing user flow, you should anticipate branches and loops in how people move through the program and plan how Python will handle these paths efficiently. In a library checkout system, users may repeatedly choose to search, borrow, return books, or exit, so a main loop that runs until they quit works well. Each menu choice can be handled by its own function with a smaller internal flow. If you need to log transactions or maintain a catalog, decide where file operations belong in this structure so that user actions clearly map to program responses and the final implementation is straightforward. In this lecture, you learn to select a beginner-appropriate Python project idea that matches your interests and skills, break the project into clear, manageable tasks and components, and design a simple plan that maps tasks to Python features such as functions, loops, and files. Congratulations on completing this course.
Thank you for your attention. See you all in the next lecture.